Hello, welcome to AP Daily. My name is Dan Bonarigo, and I teach at Riverside Brookfield High School in Riverside, Illinois, just outside of Chicago. This video is on topic 1.4, identifying and correcting errors. In this video, we'll learn that programmers need to come up with testing schemes in order to ensure programs are working as intended. So what specifically we're going to learn? Well, the learning objective is to be able to identify inputs and corresponding expected outputs or behaviors that can be used to check the correctness of an algorithm or program. So we also want you to understand that in the development process, testing uses defined inputs to ensure that an algorithm or program is producing the expected outcomes. Programmers use the results from testing to revise their algorithms or programs. Defined inputs used to test a program should demonstrate the different expected outcomes that are at or just beyond the extremes, the minimum and maximum of the input data. And program requirements are needed to identify the appropriate defined inputs for testing. So let's look at some examples. When do we start testing a program? Well, programmers start testing a program at the onset of development. Well, wait a minute, how can that be? Well, or at least they think about testing, right? So the important part is when programmers start programming, right? As soon as they start programming, they determine the program specifications, right? Which means they start trying to answer the question, how will we know if the program is working properly, right? Because if they don't ever think about this, they might never know, right? They might have a program and they might say, oh, good, this is done, right? Now, this is an important thing to think about when you are working on programs for your class, right? As soon as you start, you have to ask yourself, well, how am I going to know that this program is working properly, right? So specifications influence your testing, right? So recall that program specifications list the behaviors, events, and corresponding responses or outputs the program is to support. Programmers need to define inputs that will determine whether or not the program specifications are met. So when you start programming something, you say, okay, well, I want it to do this when this happens, and I want it to do this when this happens, and I want it to do this when this happens. And so then you need to be able to test accordingly. So let's look at an example to think about this problem. All right, so let's take this algorithm. It's designed to find the minimum number in a list, right? And so I have list is question mark, right? So we're going to assign some unknown list to this program. All right, now, if you haven't used list before, don't worry about that. We're really just trying to make sure that you understand kind of the process, okay? So before ever writing this code segment, we must think about the lists we will use to test this algorithm. All right. So, by the way, this algorithm does not work, or at least it does not always work. So, there are certain lists, certain collections of numbers that I could use that would make this algorithm display the minimum. All right. So, it's important that we understand that when we are setting out to test something, we need to just make sure that we understand different examples that could be inputted or that could be used to verify that the algorithm is indeed working as it was intended. All right. So here's our algorithm. So which of the following lists would show that this algorithm does not work as intended? All right, so let's just make sure we understand what this is doing, right? So basically, you're starting with the first element in a list, and you're going to ask, is this element less than the subsequent element or the element that follows it in the list, right? So we're going to ask, okay, in part A, is 1 less than 10? Yes, that's true. So the minimum is 1, okay? Then we're going to increment the index. And so now we're going to say, okay, is 10 less than 3? No. So the minimum is still 1. Is 3 less than 0? No. So the minimum is still 1. Is 0 less than 5? Yes. So the minimum is 0. And we've been through the entire list. And so now we display 0. So, all right. So pause the video and see if you can determine which one of these will show you that the algorithm does not work as intended. All right, so did you figure it out? Well, clearly A isn't the answer. Okay, C is actually the answer, right? So remember, okay, this algorithm was supposed to display the minimum number in a list, but it didn't for C, right? If I look at C, it would display 4 as the minimum. And obviously 4 is not the minimum, all right? B would have displayed -2 as the minimum because that's the last time an element was less than the element after it. All right. And D would have displayed 2 as the minimum, and 2 is the last time that an element in the list was less than the element that follows it. All right. So let's try another algorithm. All right. So this one is a little bit easier of an example. This code segment is designed to output a message to the user based upon the temperature. It should output, watch out for snow, if the temperature is 32 degrees or less. All right, so take a look at that algorithm, okay? And let's ask the question, which of the following input values would show that this algorithm does not work as intended? Okay, keeping in mind that we were intending for this algorithm to display, watch out for snow, if the temperature inputted was 32 or less. So pause the video and think about this question. All right, so did you come up with the answer? So B, okay, 32 would show that this algorithm does not work as intended. Why? Well, because we said that it should display watch out for snow if the temperature was 32 or less, right? So a value of 32 would not execute as true for display the snow, all right? So that one is a border case example, but it's important to understand what values we should test so that we can come up with an appropriate solution. All right, so how does this influence program development? Well, once the inputs and corresponding outputs are determined, programmers test, test, and test. Okay. After testing, programmers use the results to revise, refine, and improve their programs. Right. And then they test them again and again. Then after the programmers test, then users test. And then the programmers refine even more. And finally, the program is released. Now, once the program is released, then users use the program and then they still find mistakes, right? And so then the programmers need to go back and they need to edit and update and come up with new versions of the program that fix all of the problems they had with the old versions, right? But ultimately, that is how testing and defining testing procedures can influence program development. All right, so what should we take away from this AP Daily video? Well, we should be able to identify inputs and corresponding expected outputs or behaviors that can be used to check the correctness of an algorithm or program. Right? And we should be able to understand all of the different aspects of the development process and how testing is a part of that process. Thank you for joining this AP Daily video.